Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Hello, grade 8 learners. Welcome to today's natural sciences lesson. My name is Mr. Sianda Madala, and this lesson is proudly brought to you by the Gauteng Department of Education. Right. Remember last week we were talking about the components of a circuit, right? So today I want us to look at series and parallel circuits, and starting off with series circuits, and which is also the topic that is found under the strand, energy and change for our term 3, which contributes about 32 marks in your exam. So now let's move on to the lesson objectives and see what we need to achieve by the end of this lesson. So by the end of this lesson, you should be able to define series circuits. You should be in a position where you can tell us what a series circuit means. And also, you should be able to explain how components are arranged in series circuits. So today it's all about series circuits, right? Defining circuits, series circuit, and also explaining how components are arranged in a series circuit. Thirdly, you should be able to draw diagrams of series circuits. And lastly, you're going to investigate the effect of adding resistors to series circuits. And all that information is found under the CAPS document, page 49. Now, let's look at what we have done in the previous grades prior to today's lesson, right? So in grade 5 and 6, we have talked about circuits and current electricity. We have talked about circuits and also current electricity. I hope you still remember that part, right? But if you don't, we're going to remind you in today's lesson, right? So now, let's look at this baseline activity. Let's test ourselves of how much we know so far, right? So now let's look at number 1. Number 1 says, draw a simple open circuit diagram, right? Draw a simple open circuit diagram. That's what you need to do for number 1. And number 2, you need to tell us what will happen in the circuit if the switch is turned off. Then number 3, you need to tell us what is the importance of a fuse in a circuit. Number 4, you need to draw the symbols of the following components. The components are a cell, a switch, and a light bulb. So it's 4 questions, but there's some drawings involved, right? So you need to take good 5 minutes so that you are able to finish off this baseline activity. So we'll meet again after 5 minutes. contact us if you have any questions or any comments during this lesson. Here is our WhatsApp interactive number. It is 079 578 208. You are more than welcome to send those comments and questions. So now, let's look at the solutions for our baseline activity. Number one, you have to draw what? A simple open circuit diagram, right? And here is a simple open circuit diagram. It has an open switch, it has a light bulb, it has a wire, and it has what? A source of electricity, which is a cell, right? So now, because this is a drawing, I'm going to give you 1 minute to copy down the corrections for it, then we continue. Welcome back, grade 8. Are you winning? Are you able to draw those circuit diagrams? I hope you are, right? So now, let's look at number 2. Number 2 was saying, what will happen in the circuit if the switch is turned off? What will happen? The light bulb will be off, right? Then you give yourself a tick for that. If not, you can copy down the corrections now. Number 3, it says, what is the importance of a fuse in a circuit, right? What is the importance of a fuse in a circuit? The importance of a fuse is that it is an electrical safety device that operates to provide over current protection of an electrical circuit. Then you give yourself a tick. Now let's move on to number 4. Number 4, it says, draw the symbols of the components, that is a cell, a switch, light bulb, and a resistor, right? And here are our corrections, right? Now, for switch, this is the one if it is an open switch or it is an off position, and this is a bulb, and we have what? A cell, and we have what? A closed switch, that's when it's on, and we have what? Resistors. So now also for these drawings, we can take a minute to copy down the corrections, then we can continue after that. Right. Now I hope you have enjoyed our baseline activity. I want us now to move on slowly but surely, right? Still continuing about our topic on series circuits. So now let's look at the terminology that is involved in this topic. The first one there is our main meal, right? Which is series circuit. What is a series circuit? A series circuit is a circuit in which the current flows along one pathway without branching or dividing, right? It follows one pathway. And we also have what? Resistor. which is a component in a circuit that can block or oppose the flow of current or the flow of electricity. It is a component in a circuit. It has the ability to block or oppose what? The flow of electricity. We also have load. What is a load now? A load is any device in a circuit that uses the energy that the current delivers, right? That's all the terminology that is involved and you need to focus on for today's lesson, right? So now, let's move on. Series circuits. Let's start by redefining again what? Series circuits. We said that a series circuit is a circuit in which current flows in one direction. It follows one pathway without branching or dividing, right? And here is an example of a series circuit. So now, let's say this is a closed switch and we have current flowing, right? So it follows what? One direction without branching out to other branches, right? It follows one pathway. It flows along that circuit now and then, right? Repeatedly so. So what happens here? The direction of conventional current flow is from positive to the negative terminal of the battery. So now, revising back to our lesson about components of a circuit, can you identify a battery here, right? Can you be able to identify a battery here? Yes, the battery is this one, right? And we said that a battery has a positive terminal and a negative terminal, right? So now, we are saying now conventional current flow is from the positive terminal to the negative terminal of the battery. But remember one thing, it is along a conductor and what? Following one pathway. So this is how it flows, right? This is our positive, the long arm is our positive, and the negative one is the short arm is our negative terminal. So it follows one pathway like this, right? From the positive to the negative terminal. It keeps on going like that in one pathway without branching out. So it is ongoing like that. The energy is reused, right? From positive terminal to negative terminal, now and then, right? Following one pathway. Now moving on. We said that a series circuit provides only one pathway for the electric current to pass through it, right? So what happens? All the current that flows, it flows through each component without dividing. So it's going to be used up in each of the components that are in that series circuit without dividing. So it means what? The current is the same as it moves along that conductor. The amount of current is the same through each part or the component in the circuit. What do I mean when I say the current is the same? So meaning from the source of electricity, if you have 5 amperes of current, right, what is going to happen? You're going to find 5 amperes along the bulb. You're going to find 5 amperes of current along this wire, right? So it's the same throughout. As it flows here, the energy or the electric current that flows here is the same throughout in each component or each part of the circuit. So it's 5 amperes all around if from the main source you got 5 amperes of current. So now, moving on. If another component is added now to the series circuit, if another component is added, the whole current is going to what? Is going to be affected. The current in that circuit is going to be affected. How is it affected now? Right? It's because now they're going to share that electric current. They're going to share that energy, right? So if any of the resistors or components in the series is removed as well, what is going to happen now? The current will be broken, or the path for the current will be broken, meaning that there will be no flow. So now note this. If you add more resistors on that series circuit, it is going to be affected, right? And if you remove as well, it is going to be affected. And in that case, it's going to be affected and the current will not flow in a circuit. This is what I'm talking about here, right? So you have what? Current flowing here, right? So now notice that this is an open switch, right? As the switch is open, there is no room for what? For this current to pass through to the other side. This is because now we have opened the switch, right? It is what? It is affected. So now, if we say this is a closed switch, it is able to pass through and flow throughout the whole circuit, right? So now let's look at an example of if it is any component is removed. So now let's draw another series circuit here. We have a cell and we have a light bulb. We have wires connected to it. And yes, this is a closed switch so that the electrical current can be able to flow. So what happens here, right? There is a flow, right, from the positive terminal to the negative terminal of the cell. So what happens here? If you remove one component, so now let's say we remove this light bulb from this series circuit. What is going to happen here? Current will be broken, right? It won't be able to pass through. So now let's remove this light bulb so that you can see what I'm talking about here, right? The light bulb is removed, right? The light bulb is removed. So as the light bulb is removed, there is no flow of current. The current is broken. Same as when you remove a cell, right? There is no flow of current in that electrical circuit because one component has been removed from it. Now moving on. The simplest circuit that can be drawn is one that has what? One resistor. And in this case, what resistor are we talking about? We're talking about a light bulb, right? A light bulb is an example of what? A resistor. So the simplest circuit that we can have is that one that has what? One resistor. And also, to estimate the amount of resistance, torchlight bulbs or LED light can be used as a resistor, and the relative brightness will tell us about how much current we have, right? The relative brightness of the bulbs will indicate the amount of current through the circuit. Now, let's learn how to draw a series circuit. Remember, a series circuit, it follows one pathway, right? And a simple circuit has what? One resistor, and it needs to have a main source of electricity. So now let's start drawing together. We have what? The first wire. We have a light bulb, and we have what? Another wire connected to the light bulb so that electricity is able to pass through. We have another wire. We have another wire connected again, and we have now the main source of electricity, which is a cell, and in this case it is a what? A battery, because they are more than one. They are two, right? Negative and positive, right? Negative and positive, and we have what? A battery as our source of electricity. And then our series circuit is complete, right? But note this, it has what? It has a resistor and the main source of electricity. So electricity is able to pass through here, right? It is able to pass through, and it follows that conventional current route, right? From positive terminal to a negative terminal of the battery. So now, what is happening in this circuit here? It has only one resistor in the form of a light bulb. And also, the total resistance in the circuit will be small. Why are we saying that? Because there is only one resistor present. Remember, a resistor can or is able to oppose the current flow. So there's only one resistor opposing the current flow here, right? So hence, what? The total resistance is small. And also, don't be bothered by this, right? The position of the resistor in a series circuit does not influence the amount of resistance in a circuit. So meaning it can be placed anywhere and it won't affect what? The amount of resistance in that circuit. And also, if the number of components stays the same, the total resistance also stays the same in a series circuit. So now, talking more about series circuit. However, if more resistors now are added to the circuit, what is going to happen? The load on the circuit will increase and the total resistance will also increase, right? Remember, load is any component in a circuit that uses up the energy, right? So now the load will increase as you add more resistors, and also the resistance in total will increase. So this means what? It means that the overall current in a series is reduced, right? The current now is reduced because there's more resistors opposing the flow of current. It is reduced or it decreases. So the effect of the reduced current on the light bulbs will also become, what? Dimmer. So now, I've put now a website here for you, and it's called FET Simulations, right? I want us to try and use these FET simulations, which you can also try at home alone, right? So that you can be able to construct your own circuits and work things out, right, on your own. So now, let's visit this site so that we can be able to do our own circuits and also see the effect of adding resistors and so on. So now, here you choose lab, then here you have all the components that you need, right? You have all the components that you need for constructing a circuit. Remember, today we're talking about series circuits. So we're going to construct a series circuit. So now we're going to put the first wire, right? We're going to put another wire here so that we have what? A full circuit, right? And we're going to put another wire here to connect. And now we're going to put what? A resistor, which is a light bulb. And we're going to put another wire here next to our resistor. And we're going to put the main source of electricity, which is a cell here. We're going to connect another wire here. And remember, we need what? We need a switch, right? So that we can be able to turn on and off, so that we can have what? Control of the current that flows in. Now we have what? A switch, right? So now, here we have our series circuit now. But look at this. The switch is open, right? So what is happening here? There is no flow of current. So now let's turn on our switch. Now look at this, right? Let's look at this. Now the light bulb is lit and shining, right? The light bulb is shining to show that there's what? There is flow of electric current in this circuit, right? It flows and it goes in and out of the cell, right? As it flows, what's happening? The resistor is using up the energy, or the load is using up the energy that is in that circuit to light up this light bulb, right? So now, let's look at when we are connecting two light bulbs now. Now look at this. As I cut off that wire, what happens? I removed a component, right? So what happens? There is no flow of electricity. So now let's put another light bulb here to see what happens, right? So now let's look for a wire to connect these two light bulbs. So now, here again, right, there is flow of electricity. But notice what happens to the light bulbs there. Now they are becoming dim, right? But don't worry, we're going to explain that further, and we're going to talk more about that further. Now let's go back to our lesson, right? Moving back to our lesson. Right. So now we're still on series circuit now. So now look at this, right? This light bulb here is what? This series circuit here is having 3 light bulbs connected in series, right? So what happens here? The current has to flow through each light bulb, like the one we had on our simulation here, right? We have current having to flow in each light bulb, right? So as it has to flow through each light bulb, the overall resistance in the circuit increases because of what? It increases because each light bulb slows down the current. Remember, light bulbs are forms of resistors. They use up the energy as well. They oppose the flow of current, right? So each bulb slows down the current. And that's why you saw those ones becoming dim as you add more light bulbs. And also the charges have to do what? They have to work hard as they move along this circuit. They have to work hard. Hence, you have what? these light bulbs being dim. The charges have to work out to get through each light bulb, and the energy is used up as they do so. Not only that, right? The more resistors are, the more the energy is used. Hence, the issue of these light bulbs becoming dim, because you have added more and more light bulbs as resistors, and each and every one of them uses what? Energy. Hence, the current decreases. So the result is that the light bulbs become dimmer for each one as you add to the circuit, right? So now, let's do this practical investigation now, right? Let's engage in this practical investigation. We're going to bring a circuit board here and connect everything for you so that you can be able to see it live, right? So now, remember that our aim for this investigation is to observe the effect of resistors connected in series in a circuit. That's what we're aiming to do in this investigation, right? What materials do we need? We need cells or batteries. We need a circuit board. We need a conducting wire. We need several light bulbs. And how are we going to do it? We're going to connect what? A circuit in series. We're going to make what? A note about the brightness of the light bulb, the first light bulb. And we're going to add more light bulbs in series, but one at a time. And as we're doing so, you have to record your observations after each light bulb is added. Then we're going to keep on adding light bulbs until the light bulbs become dim and record what? Our results. And lastly, we're going to unscrew or disconnect one of the light bulbs. So now, let's just take about 3 minutes so that we can be able to collect our stuff and be able to present to you. work, grade 8 learners. Now, remember, if you still have any questions or comments, our WhatsApp number is 079 578 So now, here we are in our lab, right? Trying to check the effect of what? Resistors as you add them in a series circuit, right? So now, we have a circuit board. We have cells that are connected in series. We have some wires. We have a switch. And we have what? 3 light bulbs, right? So now, remember that we said that we're going to firstly connect the first light bulb, right? So now we have a positive terminal connected to the positive terminal of the cells, and we have a negative terminal to our switch and also to our light bulb. So now let's connect and see the brightness of this light bulb as we connect, right? So now here is the connection, right? Now it's not shining, right? What is happening? The switch is open, right? So now we close the switch. Now can you observe what happens, right? I want you to observe what happens here and note it down, right? What happens to the brightness of this light bulb, right? So now I'm going to open the switch again and be able to connect the second light bulb. So now let's disconnect this one and let's connect the second light bulb. I want you to observe also what is going to happen to the brightness of the light bulbs as I connect the second one, right? So here, let's connect. Again, we need to close the switch, right? So now I'm closing the switch. Now, there's some bit of change, right? There's some bit of change. Observe what happens to the brightness of these light bulbs. Now note that they are connected in series, right? Everything here is connected in series. It follows one pathway, right? So observe the brightness of these light bulbs. Record your observations. So now, let's connect the third one. I'm opening the switch and I'm connecting again, right? Now let's put the third light bulb. Now let's close our switch. Right? Now observe, right? As you add more light bulbs, what is happening to the brightness of these light bulbs, right? So now look at this one, look at this one, look at this one as well. So now we said that also we're going to disconnect and see what is going to happen, right? So I'm going to disconnect this one and now observe what happens, right? What happened? I hope you're noting down your observations. So now let's take 2 more minutes so that we can be able to go back to our lesson. Welcome back, grade 8 learners. We are still waiting for those questions and comments on our WhatsApp number 079 578 2908. We're waiting for them and we're gladly able to answer them to you, right? So now, let's move on with our lesson. Here is a class activity. I want us to test ourselves based on what we were looking at on the practical and what we know so far in terms of our series seconds. Let's look at the questions. Number 1, it says, how did the brightness of the light change with each light bulb you added, right? So now I showed you two things, right? The circuit board and that PhET simulation, right? So you must be able to answer this one. Number 2, how many light bulbs did we add in total to make it dim? Number 3, what component reduced the brightness of the light bulbs? And number 4, what happened when you disconnected one of the light bulbs from the circuit? So now take 5 minutes and answer these questions. Welcome back, grade 8s. Are you winning? Are you able to answer those questions? Now we are waiting for your answers, right? 079 578 2908. Now let's look at the solutions. Number one was saying, how did the brightness of the light change with each bulb you added, right? What happened? It changed, it was reduced, right? And they became dimmer, right? They became more dim. Number two, how many light bulbs did we add in total to make it dim? Remember, we added how many? We added 3 light bulbs, right? We added 3. And number 3, what component reduced the brightness of the light bulbs? It is the what? It is the addition of another light bulb, because light bulbs are resistors as well. Number 4, what happened when you disconnected one of the light bulbs from the circuit? This is what happened. No current flowed in the circuit, right? The circuit was open. So now take a minute to copy down these corrections. Welcome back, grade 8s. Now, let's move on and summarize what we have learned today. So today we were talking about what? Series circuits. Were you able to define series circuits? Were you able to explore components of or arrangement of components in a series circuit? Were you able to draw series circuits? Now, let's summarize what we have learned for today. Now, we said that a series circuit provides only one pathway for the current to pass through, right? It follows only one pathway. Now think of a hose pipe, right? A hose pipe that is transporting water. It only follows one pathway, right? For the water to pass through or to travel through it. That's how a series circuit also is, right? It follows one pathway. And also, as it follows one pathway, the direction of convectional current flow is from the positive terminal of the battery to the negative terminal of the battery. Right. Remember that batteries or cells are like this, right? This is the symbol. We have the long arm and the short arm, right? So what happens? In that circuit, they move, or the current moves from a positive terminal to a negative terminal. So who can point out a positive terminal for us? Yes, it is the long arm, right? And the short arm is the negative terminal. So this is the convectional current flow. It moves from the positive terminal along this series circuit, which has only one pathway for the current to flow, and it goes into that negative terminal. I hope we understand that one so far, right? And also, the current is the same everywhere in the series circuit. But every time a resistor is added in series, the overall current in the circuit decreases. What happens here, right? The current is the same everywhere. We mean that if you have 5 amperes of current from the main source, you're going to have 5 amperes along this conductor, 5 amperes of current along this conductor, 5 amperes of current along this light bulb. It is the same everywhere unless a resistor is added, and that's when the current is shared amongst the resistors or components of that series circuit. And also, if any of the resistors or components in the series circuit is removed, the pathway is going to be what? Is going to be broken, and as a result, no current will flow in that circuit. So now let's try and remove one here, right? Let's try and remove one. So we have removed the light bulb. As you remove the light bulb, what is going to happen? There's going to be some space here, right? The space allows for the current to not flow through, right? Because now the current is, or the pathway is broken, and the current is not able to pass through to the other side, right? And that's mostly about what we have learned for today, right? How to draw a series circuit, how to define series circuit, and also how to align components in a series circuit. So now, here is a homework activity. Let me read out the questions for you. Number one says, one word for a circuit that provides one pathway for current to pass through it. You have to give us that terminology, right? That term. Number two, you have to draw a circuit diagram with 3 cells in series. So now I want us to take 2 minutes to copy down the homework. Welcome back, grade 8 learners. So now I hope you were able to copy down your homework, right? Remember, you just need to give us one word for a circuit that provides one pathway for the current to pass through it. Then number two, you draw a circuit diagram with 3 cells in series. That's all that you need to do for your homework. So now, in the next lesson, we're going to be talking about what? Parallel circuits, right? We're going to be talking about parallel circuits. So I want you now to take your time and observe what is happening in parallel circuits as compared to series circuits, right? We're going to talk more about parallel circuits in the next lesson. So now, those of you who still have questions, who still have comments on this lesson, right? We have a WhatsApp slide for you in which we'll be waiting for your questions or comments for this lesson, right? So I'm going to give you about 3 minutes to give us those questions and comments. So now let's meet again after 3 minutes. Oh wow, we have a learner here asking a very good question, right? He is saying, what is the difference between a series circuit and a parallel circuit? Wow, this learner is ready for next week, right? Now, to answer your question, a series circuit has only one pathway for electric current to pass through, whereas a parallel circuit has more than one way for electric current to pass through. So now I hope you also come ready next week as this learner is, right? So now, to conclude our lesson, we have to click on the complete and continue button, right? To show that you have done watching this lesson, right? So from me to you now, keep on respecting your elders, respecting other learners, and respecting yourself. Thank you and goodbye.